I hope you are all good, right? And your preparation going to be in a right direction. I am TRIPATHI, Faculty, Department of Mechanical Engineering. So today, from today and tomorrow, we'll start the GATE Score Booster series for the second subject related to the Mechanical and Civil Engineering Department, that is your Fluid Mechanics. My dear, Fluid Mechanics is a little bit easy. That means the Fluid Mechanics is an easy topic, but you have to make a continuous practice to it. Without practice, you cannot solve the GATE questions. Why? Because sometimes the question is very tough. Not tough, that means the question is related to the very concept also. So in this subject, we have to discuss, so what is the strategy of this subject? You have to focus more and more on the theory part, also on the derivation, and also try to solve the numerical also. So to analyze, to boost your score, that means to enhance your score, I will come in. I come in front of you with the some good question which really helps you. Okay, hi Saurabh. So the first question, so we have to take the question step by step. That means first chapter, second chapter, like that. That means the first question we have to see in here from the related to the property of the fluid, that is your viscosity. Okay, so in the viscosity, properties of a viscosity. So see this question are really very good questions, and this is also my favorite question. What is that? You know that there is a disc is there. That means in old days there is a music players in which there is a disc, and you have to put a wire on it, and they are contacting, and the music will start. Okay, so what is that? The red wire head of a hand handle music player. Okay, so this is a music player, has a surface area. That means this needle surface area is given 0.04 mm square. The head is held 0.04 micrometer above the disc. That means this is your disc, and this lid is above the point. That means there must be a gap between the lid and the disc. And what is the gap? Gap is 0.04 micrometer above the disc, which is rotating at a constant rate of 1800 RPM. That means this is rotating. This disc is rotating, and you have to assume this is your fix. So this is your disc type, and this is your needle. So this disc is rotating, and this is your needle. So needle is fixed, and disc is rotating. So the disc is rotating speed is 1800 RPM. Determine the torque. That means you have to find the torque that must be applied to the disc to overcome the frictional shear resistance to the air between the head, that means head of the lid, and the disc. And the disc, the surrounding air is at a standard atmospheric pressure and a temperature of 20 degrees centigrade. That means what is the surrounding? Surrounding is a standard condition. Okay, assume that the velocity profile linear. That means the gap is very thin and the velocity profile is linear, and this says that the viscosity of the fluid, what fluid is there? Air. The air viscosity is very less. That means 18.1 cross 10 to the power minus 6 Newton second per meter square. So my dear, why you have to find the torque? Why you have to bother to find the torque? Why? Because if you find the torque, you can easily find the power. That means power, how much the power will consume to rotate the disc. Why the power is consuming? Why? Because in between these there is a fluid, and fluid have a friction. So due to this friction, there must be a viscous force is there, and that viscous force is a resisting force which will try to resist the rotation of the fluid, rotation of the disc. So we have to compensate that viscous effect. We have to try to find the prime parameter known as torque. So once you have know the torque, what is the torque? Once you have know the torque, you can easily design what is the power required to rotate this disc. That means you have to design the motor. So in this one there is a motor is there, and due to that motor the disc is rotating. So you have to easily define rating the motor power. Okay, so we have to find the torque of this disc. What is the torque is applied? So see, this type of problem related to the viscosity, the step is very fixed. What is that? First, you have to find the shear stress. Once you have to find the shear stress, you have to find the viscous force. Once you have to find the viscous force, you can easily find the torque. How to find the shear stress? You have to find the shear stress according to the Newton's law of viscosity. So we know that in this one, how to decide that if the Newton's law of viscosity is applied? Why? Because there is air, and we assume that air as a Newtonian fluid, so we have to easily apply the Newton's law of viscosity. So from the Newton's law of viscosity, you can easily find the viscous shear stress. Once you have to find the viscous shear stress, you can find easily the viscous force. Once you have to find the viscous force, you can easily find the torque. Clear? This is clear? So start this one. So my dear, start this one. 1 second, beta. Okay. Start. How to start, please, anyone? How to start this problem, please, anyone? So my dear, what is given here? Given. It is visible, everyone? It is visible? Yes. What is given here? Here, area. That means the contacting area. This is your contacting area. That means the area of the needle. So area of the needle, it is given 0.04 mm square. The area of the contact, okay, and the gap. That means the thickness in between the gap. Let's suppose the gap is very small, and this is your 0.04 micron. Okay, and the disc is rotating at a RPM 1800 RPM. This disc is rotating, okay, and the viscosity it is given. This viscosity is air. Air viscosity it is given 18.1 cross 10 to the power -6 Newton second per meter square. Okay, it is given, and we have to find torque. You have to find the torque which is acting on it. Okay, and the fluid is air. What is the fluid? Fluid is air, and air is a Newtonian fluid. Newtonian fluid, okay? Okay, this is clear. So these are the given, these are the according to the given condition, right? So the disc is rotating. So my dear, we have to find, so disc is rotating and there is RPM it is given. So from that RPM we have to easily calculate the angular velocity. Once you have to calculate the angular velocity, you can easily find the tangential velocity. Let's suppose there is a disc is there, okay, this is your disc, and it will, the n RPM it is given. So from n RPM you can easily find omega. This is radian per second. So 2 pi n upon 60. Once you have to find omega, so this is omega, and if you multiply omega into r, this radius of the disc, r. So omega into r is what? Tangential velocity. Let's suppose this is u. So you can easily find the tangential velocity. U. So these are the first prime motive. These are the tangential velocity of the disc. So we have to find the omega value. What is the omega? Omega is how much it is? 2 pi n upon 60. If you put the value 2 pi into 1800 divided by 60, how much it is? it is approximately 60 pi radian per second. Okay na? So we can easily find the velocity of the disk. Thus, hence, the velocity of the disk is velocity of disk is, let's suppose this is u and u is equal to r into omega. What is r? R radius of the disk is how much? The radius, this radius is 8 mm. This radius is 8 mm. So mm convert into meter, 0.008 into what is the omega? Omega, it is your 60 pi. So how much it is? This is your approximately 0.48 pi meter per second. So this is nothing. This is your tangential velocity. This is what beta? This is what? Tangential velocity. This is your tangential velocity. This omega u is your tangential velocity. Now, once you have a tangential velocity, that means how to identify that tangential velocity. So we have a diagram like that. See, see this one, beta. Let's suppose the disk, this is your disk na, this is your disk na. So let's suppose this disk, this is your disk, and this lid surface area it is given. This lid surface area is given. Lid surface area it is given. So this lid is what? Spherical. The end is your spherical. Conical is there. Cone is there. A cone, it is a sphere like a pencil tip. If you write from the pencil, the edge of the pencil tip is like a very small spherical hemisphere. Now, if you sketch it, if you draw it, so from that sphere, the curvature, that means the gap, in that gap, the disk gap, that means projection, it is like a cylindrical gap. It is like a cylindrical gap. That means a cylindrical like that. That means this is your like a cylinder. Okay, this is your gap. Okay, this is your gap. Okay, and this gap, that means this is your gap on the disk, which at a radius 8 mm. So this gap, that means there is a disk is na, see this one, there is a disk and the gap, this is your gap, this is your gap. Let's suppose this is your cylindrical shape, it is like that, it is like that gap it is there. So this gap, it is at 8 meter and this gap is moving, that means along the disk this is moving. So the movement speed, that means a tangential speed, is your u is your tangential speed, u is your tangential speed. So this is your u, that means this is moving with the velocity of u. So this is moving. Let's suppose okay, so here is needle is there, here there is a needle, yes or not? So this is your needle, this is your needle, and from the needle to the surface of the disc, so this is your surface of the disc, this is your height. What is the height? This height is t, thickness it is given, and in between this there is air. What is that? Air is there. So this needle and the disc surface of the gap, it is your t. and the T is the thickness of that gap between the needle and the surface of the disc. Okay, and the disc is rotating with a velocity, that means a tangential velocity of 0.8 pi meter per second, 0.48 pi meter per second. That means this is your moving, that means the air, this is your air. Okay, so the air on the disc is also moving with the velocity of this velocity u. Okay, why? Because there is a no slip condition, and at the tip the air, it is at rest. At the tip, this is your tip, needle is rest position, no slip condition, and the air particle on the disc moving with the velocity of disc. So here is a gap, here is a linear profile. Why? Because the gap is very minimum. The gap is very minimum. So this is your velocity profile. This is your velocity profile. Now, now, if you think about that, this is your disc. Okay, so this is your u velocity. Now, if you write, there is a disc is there. If you write like that, if you draw like that, see. So there is a disc also. Okay, no? This is your disc, this side, this is your disc. Okay, and this disc, let's suppose this disc okay. Okay, so now my dear, this disc is rotating. This disc is rotating, that means this disc is rotating. Okay, na? This disc is rotating with omega velocity. Okay, and if this disc is rotating on the disc, on the disc there is air, so air is also rotating. So that air will produce a viscous force on the disc. Why? Because the air have a viscosity. So the air will produce a viscous effect. So in between this disc and the needle, there is a viscous force, and viscous force always oppose the motion of the disc. So motion of the disc, it is in anti-clockwise. So the force, it is in clockwise. So needle is at here. So this is the position of the needle. Let's suppose this is the position of the needle at a radius r. So at this point there must be a, so this is your arc is there, at this is your roundness, at this path the needle is moving. So needle is at here, so the disc is moving, so there is a circular path is there. So this path, on this path there is air is there. So the air will produce a viscous effect, and that try to slow down the disc. So the that means in which direction? Opposite to the motion direction, opposite to the motion direction, in this direction. So in this direction there is a viscous force, or you can say that drag force, anything you want to say. So this is your viscous force or drag force. This viscous force and a drag force on the plate due to the air. So this viscous force or drag force, who is the responsible? Due to the air viscosity, and it will be viscosity produce viscous force on the plate, this produce a viscous force on the plate. So how to find this viscous force? To find this viscous force, we have to apply the Newton's law of Newton's law of viscosity. So how to find this viscous effect? First we have to find the shear force. What is the shear force in between this? See, this is velocity gradient. So this is what? du over dy. Let's suppose this is your y direction. This is your y direction. This is your y direction. So du over dy, it is there. So this is your gradient multiplied with the coefficient of viscosity of the air. So there is a shear stress. And what is the shear stress? Force upon area. Force upon area. Area it is given. This is the area. This area it is given. This area it is given. Yes or not? This area it is given. What is the area? Area of the needle. This area of the needle. This area of the needle. It is given. So the area, so on this one, the area, so if you multiply with this property viscosity, that comes with the shear stress. And shear stress is what? Momentum flux. So once you have to a momentum flux, you have to easily find the force. Who is the responsible? So force, how to find? That shear stress is equal to force upon area. What is the area? This is the area. So that is your calculation next. Okay. So so velocity profile is, in this question they says that velocity profile is linear. Since velocity profile is assumed to be linear. Assumed to be linear. Okay. So what is the linearity? Du over dy is the velocity profile. And if it is linear, so it is u by t. U by t, it is linear. Okay. So u by t. So this is u is any. So this is your u by t. And what is u? You have u. What is u? 0.48 pi. And what is the gap? Gap, it is your 0.04 micrometer cross 10 to the power minus 6. So this is how much? 12 cross 10 to the power 6 pi. Unit is second minus 1. Second minus 1. Why? Because this is your meter per second and this is your meter. Meter cancel, second minus 1. Now applying the Newton's law of viscosity. Applying Newton's law of viscosity. And what they say is that Newton's law of viscosity, stress mu linear u by t, and mu value it is given. How much? 18.1 cross 10 to the power minus 6. This is your mu. And u by t, it is your 12 cross 10 to the power 6 pi. Clear? So if you calculate the shear stress, it is your 217.2 pi Newton per meter square. Stress unit is force per meter square. Now, so once you have to stress, what is the next step? If you have a stress, what is the next step? We know that. What we know that? The shear stress tau is equal to, this shear stress is what? Viscous shear stress. This shear stress is what? Viscous shear stress. Viscous shear stress. Also called momentum flux. Also called momentum flux. Okay. So momentum flux, that means momentum, force by area. This force is your viscous force or a drag force divided by area. From here you can easily find the viscous force. Stress you have 217.2 pi viscous force you have, and area, contacting area, it is given with see this one, the area it is 0.04 mm square. So 0.04 into 0.04 mm square, that means 10 to the power minus 6, multiply it. So it is your 8.688 cross 10 to the power minus 6 pi, and this is your Newton. Clear? This is your Newton. So this is your force which is resist, sir, that means this is your force, that force which is required to resist the motion of the disc. Why? Why? Because there is in between that there is air, and air have a viscosity, so it will resist the motion of the disc. Now to compensate this resistance, you have to require the extra power. So what the power rating of the motor you can easily find. Okay, so from this is your viscous. Now once you have to find the viscous force, you can easily find how to find the what they find that they are asking, they are asking that determine the torque. So how to find the torque? So this viscous force into the radius is your torque. This viscous force into the radius is your torque. So if you find the torque, now torque required, torque required to overcome this frictional effect, this frictional effect. That means if you want to overcome this frictional effect, so the torque is equal to this viscous force into the torque arm, R. R is the radius. So what is the viscous force? 8 point, what is the viscous force beta? 8.688 cross 10 to the minus 6, 8.688 cross 10 to the power minus 6 pi. This is your viscous force into the radius. What is the radius? Radius is 0.008. Okay, 0.008. Why you are 8 mm given? So this is your 0.218 cross 10 to the power minus 6 Newton meter. This is the torque required to overcome this frictional effect. This is your required answer. So this is your torque. So so due to the torque, and now how to find this power? That means if you want to the power dissipation, that means to overcome, so that means this torque is to overcome the frictional effect. That means what the torque are producing, that will be overcome due to the frictional effect. So how much the equivalent power to dissipate? So power dissipation, if you find that power dissipation due to viscous effect, so power is equal to nothing, torque into omega. That's it. So if you have a torque, so primary is torque. If you have a torque, anything you have to find. So if you have a torque, multiply with the omega, so that is your power dissipation. That means this power is extra power. So one is the rotating, and this power, that means at this to overcome that frictional effect, that means to overcome this frictional effect of the disc, to overcome this frictional effect of the disc, that much of the power you have to require. That means you have to set that equivalent power of that motor, so that the effect of the frictional effect is neglected. That means overcome. not neglected, that is overcome. Okay, my dear. So I hope you enjoy this question. So this question is your little bit easy, but the question is very, very, very good question. New question is there, very new question there. You didn't find any YouTube channel or anywhere. These are the very new question, and you have to supposed to be asked for the 2 marks this question. Okay. Now, my dear, before moving the further question, I have a one announcement. I have a one announcement. What is that? What is that? I have a one announcement. What is that, beta? See this one. Yes. This is very helpful to you. What is that? The IMS for the GATE 25-26, they have an online program. So this is the announcement for the online program. What is that? We have 800 plus hour live classes with a live interaction. That means live classes with a live interaction. That means the faculty, live classes is there. That means the faculty in front of you, not recorded. There is 800 live classes. Mind it, it is not recorded. Okay. Now, second one is we have a separate theory book, updated theory book. We have exercise book. So you don't bother about any textbook. We have a theory book. We have exercise book. In the exercise book, there are 3 categories: L1, L2, and L3. Mind it, beta. In the exercise book, they cover all the previous year questions related to the PSUs or anything of a level 1. Level 2, it is not GATE question, but it is equivalent of the GATE question. That means if there is a new question, that means it is level 2. It is in the level 2. It is not like that. It is a PYQ. No, but the level of that level 2 is like a PYQ, and level 3 is really whose student is very helpful for preparing the ES or AS conventional. Okay, so level 3 is like a conventional question. Now, along with that, we have, this is very important, 30 plus years of the PYQ in the same GATE questions. That means we have a 30 plus year. And what is the unique of this one? There are 2 unique features. First one have a video solution. That means a toughest question. What you have the toughest question, and what is that? If you prepare any examination and if you see the question, that means you are supposed to be solve the question. You didn't able to solve the question. So what you observe? You have to see the solution. Sometime while seeing the solution, you have unable to understand very clearly. So on that one, there is a QR code. Just scan it, and that you have to watch the videos of that solution. Number first. Number second, the question which is a tough question, really there is a tough question, at least there are 2 method, and also there is a note point is there. So all about the complete package. Third one is this is the IMS special features. That means you have a 12 personalized one-to-one mentorship program. That means, see, sometimes students are very hesitated to ask in the class. Why? Because in the class there are many students. So the student have an opportunity to book that slot, and we have to interact one-to-one. That means what your teacher to book, they are on the live and or on the physically. You have to interact with one-to-one, and also 130 plus online test series with a video solution of a mock test and many more. Right. Now, if you have any confusion or any related to query, just call this number. Okay. The second one is that if you have any outsider student, we have a Telegram group. On that Telegram group, there is an update is there scheduled for the free YouTube lectures PDF. That means today, let's suppose today I will complete the first session. I will complete the first session of the fluid mechanics. After the completion of this session, all the PDFs or the videos are available on the Telegram channel. So you can join it, and also if you miss it any particular content, you can watch freely. Important updates is there. Always there is an important update related to the seminar, webinar, all the things. And also there is a very much important that a government or PSU notification. Why? Because sometimes we have a forget. Yeah. And expert session on the important topic and daily cues. This last one is a very important. We have a posted many more cues of all the branches related to the all subject, and immediately after one day we have also provided the solution of this one. So how to join? You have to visit this one and join this Telegram group. Mind it, beta, really this is very helpful. Okay, so these are the little bit information. Now we have to go to the further as per as my schedule is there. The further is, so this is okay. Now so this question is okay. This question is okay. Now we have to move the next question, which is very important. That is your this. See my dear, this is not right now, the gate is not asking like that, but equivalent, this related problem is already asked in the gate question, and mind it, in that time the IISc Bangalore the question will set at 2016. Right now also in this year the IISc Bangalore question will set. So this question is supposed to be a very important question. I will supposed to be, I want that you can solve everyone. What is that, beta? See this one. What is the question is that there is a plug. So this is your plug in the figure of 50 mm long and has a trapezoidal cross section. So this is your plug. So this is your plug. This is your plug. This is your plug, and this plug is adjusted at the lower portion of the tank. And this plug, the length which is a perpendicular to the board is 50 mm. Trapezoidal cross section. What is the cross section? So in some time, so thank you. So sometime this is your trapezoidal section, and this trapezoidal section, what they ask, so these are the basics things. Sometime in this gate question, it may be a circular, it may be a parabolic, it may be a semicircle, it may be a triangular, it may be a cone, like the structure it is there. So we have to take a trapezoidal. So one category, it is very important. Okay. So this is your trapezoidal cross section. Okay. Trapezoidal cross section. If the tank, this tank is filled with a oil, determine the resultant vertical force acting on the plug. What is the resultant vertical force acting on the plug due to the oil pressure? So in this one there is a oil. In this one there is a oil, and this is your trapezoidal cross section. So what is the force acting? Which force? Vertical force acting on the plug. My dear, this is very important question, and they says that the density of the oil is 880 kg per meter cube. Clear? Clear? Okay. So we have to try to solve this problem. How to try to solve this problem? See my dear. This plug, the length which is perpendicular to the board is 50 mm, and the size, this size is 40 mm, 20, 10, 10, 40 mm. So this is your 20, and this portion is your 10. So this is your 10, this is your 20, and this is your 10. So there is a 40, and perpendicular to that one is 50. Okay, we have to try to solve this problem. So if you solve this problem, we have a arrangement like that already. We have to make a arrangement like that. What is that? See my dear, see, so so what is the hydrostatic law? Says that, see, this is your plug, this is your plug, to change the color, no problem. This is your plug, we have to take this color. Okay. So this is your plug, yes or not? So this says that a vertical force or a pressure. So this is your plug. On this plug, this plug. So what is the pressure on this plug? Pressure on this plug, on this surface hold the fluid. The pressure on this plug is your this portion, yes or not? This total portion. So this total portion of this total water which is holded by the surface BE, and that is up to the free surface, that is your total vertical downward force. Okay. Now, my dear, there is a side is also this. This is side, na? In this side, there is also water is there, fluid is there, sorry, crude oil is there, So this side, also the pressure it is acting in this direction. The pressure is acting in this direction. Okay, yes or no? On the side, slant side. So on the slant side, there have a component, one is vertical, another is horizontal, and also one is vertical, other is horizontal. So my dear, this horizontal component are symmetric, so it will cancel out. So only the vertical component is there. So this vertical component is upward direction, and this vertical component on the surface BE is the downward direction. So what is the net? Is your net force on the plug. Clear? So don't forget of this edge. So from this edge, if you find the vertical force, for this edge, you take the projection. So you take the projection to the free surface. So this is the projection of this vertical force. This is your projection of this vertical force. And if you find the force vertical on this slant side, keep the projection of at the free surface. Keep the projection at this free surface. So this one is the force which is upward, and this shape of the fluid. So this is shape of the fluid. Let's suppose this is volume V2. Let's suppose this is volume V2 and total volume is V1. So total volume V1 is downward minus 2 into V2. Why? Because this is V2. So total is 2. So minus of 2 into V2 is upward. So net volume, how much? V1 minus 2 into V2. What is the vertical force? What is the vertical pressure? If you say that rho GH, if you say that the volume displacement, if you say that they are saying that force, na? What they are asking? Determine the resultant vertical force. So if you find the vertical force, so pressure, what is the pressure? Rho GH, it is the pressure into the area, So what is this? Rho G, H into area is volume. This H into area is volume. So what is the vertical force? Rho G is your gamma. That means gamma of water into volume. So this is a vertical force. So gamma is rho into G is common. Rho into G for this support, rho into G for this support is common. Only the volume are different. So volume, total volume by this surface minus 2 into volume of this surface. Why? Because this surface will try to force upward direction. On this surface, the force is on downward direction. This surface is your upward direction. Why? Because fluid is there, and this surface is your downward direction. So what is the net volume? Net volume is 2 into this slant surface upward, and that means V1. Let's suppose this responsible is V1 volume and this responsible is V2 volume. So what is that? V1 minus 2 into V2. So V1 is what? V1 you have total. Okay, V1 you have total. That means this total volume is V1. This trapezoidal. So this one, this H's area. Thank you, Pratik. Thank you. This H's area is your slanted. On this slanted, the horizontal component are symmetric, so it will cancel out. So the responsible is only vertical component. So this slant surface, this is your slanting surface. So this slant up to the free surface. Let's suppose this is your free surface. Let's suppose, so you have to project this one up to the free surface. So this is your volume. So let's suppose this is your V2. So there are two, that means in this slant and this slant, that means 2 into V2. 2 into V2 minus V1. Net vertical force. Net vertical force. Okay. Net vertical force. Right. Clear? This is clear. Now we have to rub this one and now we have to try to solve this one problem. Okay. So, see my dear. First, very clear. First, see my dear. First, what you have to think like that. That means the force, pushing down, yes, this will push down. That means on this surface, the force is downward. Yes or no? The force is a pressure force is a downward. Why? Because the crude oil. Okay. So the force pushing down on the plug is due to weight of the oil contained within, this is very important, within region. Why? Because vertical force is what? Weight. So weight within the region A, B, E, F, A. That means A, B, E, F, A. This volume. This is your weight of the fluid. So region, what is that? A, B, E, F, A. Okay. Let's suppose this is your volume V1. Now, second one is the force. Now, this is a slanted surface. So, on this slanted surface, perpendicular force will produce due to this fluid. So, this perpendicular have a two, one is upward, other is horizontal. This slanted surface have two, one is upward, other is horizontal surface. So, this horizontal and this horizontal are cancelled out. Why? Because they both are symmetric. So, total is this one. So, this slanted surface project upward. So, if you project, this is your projected. This slanted projected, if you project, this is your projected. So, water hold in this region. This region. Total slanted. You don't think that, okay, sir, in this one there is no any water. That why? Because this is solid. In this slant there is no any water. So how to project? And this is flow. No, this is slanted. So project this vertically up. That means if you project, this is your project. That means project vertically up. It will project vertically up. So for this slant, this is your projection. For this slant, the volume contains this projection. Clear? So 2 into V. Okay. So the force pushing up, so this is your pushing up. Pushing up occurs due to pressure along side. What is the side? What is the side? BC and DE. BC and DE. And let's suppose this is your V2. Let's suppose this is your V2. Okay. Now, that means so resultant force Fr, in vertical direction now, my dear, vertical force is nothing, it is a weight content. Weight, that means weight holding weight. That means what is that? Density is equal to mass by volume. Okay, multiply G. So M into G is what? Weight, and this is equal to density G into volume. So my dear, this volume is volume holding by the surface. This is the volume of fluid. Volume of fluid hold. Volume of the fluid holds by the surface up to free surface. Up to free surface. Very important. So rho G is common into V1. That means V1 is your, V1 is what? V1 is your A, B, E, F, A. A, B, V1 minus V2 is your, this is your V2. This is your, this hatchet part. This is your V2. This is your V2. This hatchet part. So 2 into V2, and this total is V1. This is your V1. Total is V1. So this is your V1. This total, it is your V1. This total, it is your V1. This total, it is your V1, and this hatchet portion, this one is your V2. This is your V2. Okay. So V1 minus 2 into V2. Hi. Hello. Okay. So 2 into V2. 2 into V2. Okay. No problem at all. So what is rho? 880 it is given. G 9.81 it is given. What is the volume of that all the portion? This volume of this portion. This volume A, B, E, F, A. What is the volume? Total height is 60. 60 cross 40 is the cross section into the depth 40. Depth is how much? Depth I think 50 it is given. 50. So 50. What is the total volume? This total volume, beta, if you write like this total volume. This total volume, what is this total volume? 0.6 cross 0.4 cross depth. 0.5. So this is your total volume. This is your total volume. So the total volume is 0.06. How much? What is the unit is there? Mm. Mm is there. Mm is there. So this is mm, na? This is mm. So 0.06 cross 0.04 cross 0.05. This is your volume. This is your volume. Okay. 0.6 cross 0.04 cross 0.05. So this is your total volume minus 2 into volume of this one, V2, volume of this one, V2. So if you find this volume, first is the rectangle, this rectangle. So if find this rectangle, what is the area? Why because width is same? What is the area? 60 into 10. 60 into 10 plus area of this triangle, half 10 into 15.5. Clear now? So there are two portions. One is the rectangle. So if you find the volume of this rectangle, V2 is what? 0.06 into 0.01. 0.06 into 0.01. This is the area of this one. Multiply with this plus area of this triangle, half into, this is your 0.01 into, this is your 0.01, half, and this one 0.05. 0.1015 mm, na? So this is your 10. Okay, so 0.06, this is 0.001. So this is 10, na? So 0.01. This is 10, 60, 0.06. So this is 0.01. 0.05. Clear? Clear, beta? So 0.05, 0.01. Clear? So this is the volume. So this is the total volume, 2 into this one. Okay? Okay? So write down here, 2 into, first on this one, 0.06 into 0.01. Okay, now 0.06 into 0.01. Okay. So this is a rectangle plus triangle, half into 0.01 into 0.015. Okay, na? Okay. This is your, and into width. Width is how much? 0.05. Width, that means perpendicular to the page. Perpendicular to the page. Now, if you solve this one, the value it is your 0.453 Newton. And my dear, this is positive. That means net it is in upward direction. Why? Because we have to take the upward as a positive. Sorry, net. So we have to take. So positive. Why? Because we have to take this one V1. If you take this V1 minus 2 of V2, that means the volume, bigger volume is higher as compared to the lower volume. 2 into lower volume. So net it is in downward. Downward direction. Net it is in downward direction. Why? Because this is your bigger one. This is your bigger one. So this is your bigger one. So bigger one is downward. So this is your downward. This is your downward on this one. And this is only upward. So downward is more. So this is your V1 and this is your V1, this is your V2, and this is your V2. Clear? So in the gate question, it may be a circle, it may be a hemisphere, semicircle. So the shape is anything. So there is a trapezium, it may be conical, cone is there. So in the gate, what they are asking like that supposed to be. So this is trapezium. That means in the gate question, it may be like that. Let's suppose this is a container. In this container, it may be a semicircle like that. So how to find? If this is a container, let's suppose this is a container, it may be a semicircle like that. It may be like that. Third one, this is a first one, second one, third one. If there is a container, so it may be like that. Cone it is there. So anything is there. Anything is there. Cone it is there. Circle is there. Semicircle like that it is there. And also there is a trapezium. Trapezial is there. Okay. So this is nothing. This force is nothing. This is the force required to hold. That means this is the net downward force. So what is the force required to hold this plug? What is the net force? So this is your F. This force is the net force to required to hold the plate. F. Hi Sami, hi, how are you? Fine. Okay, so this is your net force. You are again late. So this is your net force. Okay, so it may be a trapezial shape, it may be a circular shape, it may be a triangular shape, it may be a conical shape. It is like that. So this is the force required to hold the plug against the weight of the fluid. Against the weight of the fluid. So these are the second question. Okay. So these are the second question. Mind it. Now we have to move the third one. What is that? This is the third problem. Very important. The third one is related to the force on a curved surface. So let's suppose there is a ring is there and there is a plate. That means it is like that. There is a plate is there. Okay. This plate is hinged at point B. That means at the point P, this plate may be swivel. And to support one, there is a supporter is there, and that supporter is at point A and hinge at point B, and this circle of a radius 3 meter. Okay. So what this says that, this is very important problem I am telling you. What this says that a semicircular plate in figure, this is the figure it is given, 4 meter long. That means this is your perpendicular to the board. 4 meter long acts as a gate in a channel. That means this is your act as a gate. That means at this point it may be open, it may be closed like that. Okay. Determine the resultant force, the water pressure, resultant force, the water pressure exerts on the plate, and first question, and the second one, then find the component of the reaction at the hinge and at the support. Three questions. Neglect the weight of the plate. You can neglect the weight of the plate. If it is not, if it is given, we have to count. So if the weight it is given, we have to count this weight in the vertical component of net hydrostatic force. We have to count the weight of the ring, that means weight of the plate, in a vertical component of the force. Okay. So let's start this problem. What is the approach of this problem? Please, anyone? What is the approach of this problem? Anyone, please? See, my dear. First, we have to determine the horizontal force. That means the water is holded one side. We have to determine what is the horizontal force. That means what is the vertical force and horizontal force. This is the component of net hydrostatic force. So we have to find the component of net hydrostatic force in a horizontal and in a vertical direction due to when the water is holded by the plate, curved plate. Okay, so if you do like that, same idea, this is your curved plate. Okay, A, B, C. Let's suppose this is your curved plate. On this plate there is a fluid. Let's suppose this is your fluid. So this fluid at this point the pressure is 0. And if you move deeper and deeper inside the fluid, we know that the pressure will increase. So at this point the pressure is higher. So this is your pressure triangle. This is your pressure triangle. So from this one, this pressure triangle will produce a net force in a x direction. So that is your net force in a horizontal direction, F H net. So this is your net force in a horizontal direction of a component of net hydrostatic force. Okay. Now, so now the water it is holded. That means this ring is holded water. So we have to find the vertical force. So what is that? This portion you have to take the that means you have to take the this point up to the free surface, this point up to this surface. So this much of the fluid which is this much weight. So some fluid is this side, some fluid is top side. So the weight, that means a vertical force if you calculate, so vertical force due to this fluid, vertical force due to this water is this volume content. Vertical force of this water fluid is due to this vertical component. So this is downward. So this it will produce, this is a vertical force, this is a vertical force. So if we calculate, this is your horizontal force, so this is your horizontal force, this is your vertical force, this is your horizontal force, this is your vertical force. So if you calculate this vertical force, so you have to take this projection up to the free surface. So this projection is downward. So this is a downward. If you calculate the vertical force of this component, so this is the vertical force. So this is the vertical force, this is the vertical force is upward. So what is the net vertical force? If you club this one, so if this total volume minus of this volume, automatically it is like that. So there is a total volume minus this volume. If you neglect this volume, so automatically this is the volume of this semicircle. So that means what the fluid is contained, the weight of this contained fluid within this circle is the net vertical force. Clear? Net vertical force. It is visible? Yes. Net vertical force. It is your net vertical force. Okay. So we have to start with that. So first we have to determine in this one. First determine the horizontal and vertical components of the resultant force acting on the plate. First we have to determine that. Okay. First we have to determine acting on the plate. Okay. So we have to find case first. We have to find case first. What is your hydrostatic force? What is your hydrostatic force? What is your So this is the force. So this is the force acting on the segment CB. and this is the force acting on the segment CA. CA. Why? Because the plate is not holding, it is displaced. So during, see my dear, a curve is holded with the fluid, or a curve which is displaced the fluid. So a curve which is hold the fluid, the vertical force is, in both cases, the vertical force is equivalent to the weight of the fluid. But if the curve is hold, if the curve which is hold the fluid, the vertical force is always downward. If the curve which is displaced, so this is displacing fluid, this is displacing fluid. So if the curve which is a displaced fluid, so net vertical force is always upward. See, if you, this one and this one, so downward is lower, upward is more. So net is the upward. So why upward? Why? Because it is displacing. Let's suppose if the fluid it is in this curvature, so what is the vertical force direction? The vertical force is always downward. So contained within the curve, downward, displaced by the curve, upward. Clear? Now we have to start. Case first. Case first. We have to find horizontal force. So this is your horizontal force component. Horizontal force component. We have to find horizontal force component. What is that? So my dear, for the horizontal force component, okay, no problem. We have this curve. One second. This is for the horizontal. So we have this curve. Yes or no? Okay, no problem. We have to take the shape. Okay. Done. Done. Now, so this is curve portion, this is the curve portion, this one, this is your A, C, and this is B. This is your curve portion, this is your curve portion. It is given in the question. Okay, this is your curve portion. It is given in the question. Now, my dear, we have to find the vertical force, horizontal force. So, if you find the horizontal force is what, beta? So, this horizontal force, let's suppose this is your x direction and this is your y direction. So, horizontal force, it is in x direction. So, if you find Fx horizontal force, what is that? We know that centroidal pressure rho g h bar, this is your centroidal pressure into the projected area. Into the projected area. This is what beta? Centroidal pressure. Pressure at the center. Pressure at the CG. Pressure at the CG of the projected area. Of projected area, and it will act center of the pressure CP, and center of the pressure, it is always center of the pressure. So if we find this is your, see my dear, Okay. Okay. So this is your projected area, projected line. This is a line, projected line. So over this one, there is a pressure distribution. There is a pressure distribution, yes or not? There is a pressure distribution here. Here the pressure is 0, gauge pressure. Here the pressure is maximum. So the pressure, the Fx, the horizontal force x, is act at the centroidal pressure distribution. That means this will act at this portion. This portion. So it will act at, this will act at a CG of the pressure prism, CG of the pressure triangle, CG of the pressure triangle. So the CG, this CG, why? Because this is a triangle. This is a triangle, na? So what is the CG of this triangle? This triangle CG, let's suppose this is from the base, is h by 3. This is your 6. This total, it is your 6 meter. It is given 6 meter. So it is your 6 by 3, h by 3, 6 by 3. That means 2 meter from the base. So this is your CG, centroidal. And what is the h bar? Always h bar you have to take from the, always you have to take the h bar from the free surface. One second. This is your h bar from the free surface. This is your h bar. This is your h bar. This is h bar. Now, but here we have to take the projected area. Here we have to take the projected area. This is your not h bar. Okay. So we have to take the projected area. And if you take the projected area, this is your like a rectangle. This is your projected area. This is your projected area like a rectangle. Okay. So what is the area of this projected area? What is this area? This area is height 6 cross inside, what they say that 4 meter long, 6 cross 4. So 6 cross 4. So this is your projected area. And what is h bar? So rectangle, what is the h bar? So h bar is your 6 by 3. 6 by 2. So 6 by 2, it is your CG of this rectangle. So this is our projected area. This is our projected area. This is our projected area. Okay, now? This is our projected area. Now, now my dear, write down this one. Then this is your 10 to the power 3 cross 9.81 cross h bar is your 6 by 2 centroid of the rectangle into projected area 6 cross 4. Okay. So this is what, beta? This is your CG of projected area, AP. Okay, CG of projected area. So how much it is? If you calculate, this is your 706.323. This is your horizontal force. This is your horizontal force. And this will act at CP, center of pressure. This will act as CP. And what is the CP? It is act as center of pressure, and center of pressure it is your h by 3. That means total height h, if you suppose that this is total height h, so h by 3 of the triangle from the base, that means 2 meter from the base, okay. Now what is the vertical force? Case 2, what is the vertical? So see, 7.706.32 kilonewton from the base, okay. We have to find the horizontal force, vertical. Case 2, vertical force, we have to find the vertical force. Component, that means Fy, okay na. So Fy is what? Water content, so the vertical force is what? The vertical force, you take the projection of this lower portion, you take the projection of this upper portion, so the net it is in the curve, that means volume of ACBA, so the vertical force Fy is your weight and it is your displacing, so this is your upward direction, why? Because it is a displaced fluid, okay, upward direction. And what is your weight? M into Z is equal to rho G into volume. This is volume what? Volume, volume of this sector, find the volume of this one. So if you find the volume of this one, this is what? Half into pi by 4 d square cross section area into width B. This is your volume. This is your volume of this one into rho into G. So weight is equal to 10 to the power 3 G 9.81 into volume half pi by 4 d square into width perpendicular to the page. If you put this value 10 to the power 3 cross 9.81 into half, okay, into half pi by 4 diameter 6 square into this is your 4. So how much it is? It is your 176.58 pi. 176.58 pi kilonewton. Clear? So this is your net vertical force. That means not net vertical, this is the vertical force component, okay. Now this vertical force passed CG of the, why? Because this is your, so let's suppose this is your triangle, this is your semicircle. So what is the CG of this circle? From the base, this is from the base. So from the base it is your 4r by 3 pi from the base. So this force is passed CG of the semicircle, okay. Why? Because the weight, this is the weight, and weight, the what is the center, at what center the weight is passed? CG. So weight content within this fluid. So weight content this fluid. So what is the weight? Weight passed through the CG of this semicircle. CG of the semicircle. So CG of this semicircle is what? Let's suppose this is your D and this is your D. D, yeah, you can say that X, yeah, you can say that what is that? CG. Let's suppose CG. Yeah, you can say that this is your BM. Let's suppose this is your K, and K it is 4r by 3 pi. So 4r is equal to 6 divided by 3 pi. So what is that? 8 pi. 8 by pi. So it is how? 4r by 3 pi. So 4r is equal to not 6, r is equal to 3. So 4 into 3 by 3 pi. So it is your 4 pi. So this is your 4 pi at which it is passing from the base. This is your 4 pi. So if you draw, so what is the result? So what they are asking that with the resultant force of the water pressure exerts. So what is the resultant force? This is the horizontal force, and this is your vertical force. If there is a weight is given, if there is a weight of the ring it is given, just subtract this value. That means this is the value which is holding and which is upward. That is the direction is upward. Why? Because it is a displacing the fluid. A curve which is displaced the fluid, the net vertical force is upward. If the curve which is holding the fluid, the net vertical force is a downward. So in this case, the net vertical force is upward. Okay, and if there is weight of the ring it is given, subtract this value. Subtract the weight of the ring from this value, then there is a net vertical force. Now what is the resultant then? What is the resultant? A square root of this one. Fx square plus Fy square. So if you put this value, this is your 898 kilonewton. Okay, so this is your resultant force. Now once you have a resultant force, so draw the free body diagram of the ring. Why? Because they are asking that what is the reaction at point B and what is the reaction at point A. So if this is your ring and this force is passing, this is a vertical force. This is your vertical force, my dear. So this is your vertical force. If let's suppose color change. This is your vertical force. This is your Fy and this is your Fx. So Fx is at 2 meter. Why? Because this is your center of pressure and this is your CG. So vertical force act as the CG of the fluid displaced or contained. Horizontal force act at the center of the pressure. So this is your, at this point the horizontal force act, at this point the vertical force act, and at this point there is a support. So let's suppose FA. Why? Because this is A point it is. So there is a FA force and there is a hinge. So let's suppose one horizontal, one vertical component. So hinge at B, so BX, BY, force at FA. We have to balance the force and we have to find FA, BX and BY. What is the reaction at the hinge and what is the supports force? We have to find it. So from that one we have to find like that. So we have to find the reaction. We have to find the reaction. Okay, we have to find the reaction. So we have to draw the free body diagram of plate. Free body body diagram of the plate. So this is your free body diagram of the plate. Free body diagram of the plate. Now, so let's suppose summation of all the force in y direction taking upward is positive. This is equation, static equation is equal to 0. First equation. So what is that beta here? Upward. So this is a minus bx. We have to take in this direction, y in this direction x. So this is minus bx. That's it. Minus bx is equal to fy. Minus bx is equal to fy. That means we have to take like that. Minus of by plus downward 176.58 pi is equal to 0. So what is by? By is equal to 176.58 pi. If you convert pi, so this is 555 kilonewton. So this is your reaction at point B. So this is your B point. This is your B point. So this is the reaction at point B is positive. So this is your by. Y is in which direction? You have to take any direction. So by is your downward. So at this point, by is your downward. So by is your downward. So this is your downward direction. How much it is? 555. So this is your downward direction. In this one, there is a downward direction of the hinge at 555 kilonewton. Okay. Now this is the reaction. They are saying that, and then find the component of the reaction at the hinge. That means pin at B. The component, this is one, and you have to take, this is your Bx. So we have to find Bx also. So Bx you have to find. That means Bx. So you have to find Bx. Apply net force in x direction is equal to 0, and take in this direction, right side is positive. So equate with that one. Equate beta. Now equate. So this is your 706.32 right side. This is your left side minus Bx minus FF. FA. Don't forget this one, FA. So you have to balance it. So this is your 706.32 minus of Bx minus of FA is equal to 0. Now my dear, we have to find the Bx, but we don't have this value Fa. We don't have this value Fa. So we have to find Fa. How to find Fa beta? How to find Fa? See, this is your semicircle, and here is hinge is there, and at this point there is Fa. Fa is there, okay. So and at this point there is your Fx is there, okay, and at this point there is, let's suppose B is there. So we have to balance is the moment. So summation of all the moment at point B and take counterclockwise is positive is equal to 0. Balance the momentum. So and also there is a vertical force. From that one there is a vertical force is there, which is Fy, and that Fy, it is at a distance k. It is a distance at k. So we have to take, and this distance you have 2, this you have 6, this you have 6, and this you have a k 4 by pi. So if you take the moment, that means this is Fy, write down, that means this is Fa, so Fa into a distance 6, it is in positive sense. If you take this your negative, minus of Fy, it is your 176.58 pi into the distance is 4 by pi. This is your also negative, minus of Fx, that means 706.32 into 2. This is equal to 0. This is equal to 0. So from here you can easily find what is the force at A. So force at A is equal to 353 kilonewton. 353 kilonewton. So this is your Fa. Put this value here. Put this value here. So put this value. So from here Bx is equal to 353. Done. Done. So this will Bx. This is your Fa. And this is your By. Okay, done? Done, beta? This is clear? So how to find this one? So that is clear. That is clear. Okay, beta, is there any problem? Please ask. Is there any problem? Please ask me. Is there any problem? Please ask me. So this is your, okay. Okay, so this is your all the questions related to this problem. Done? Done? So this is your horizontal. This is your net force. How to calculate? This is a free body diagram. Very important. You have to always note down this thing. This is your free body diagram. Okay. How to find horizontal force? So if you take the projected area, CG of that projected area CG is your just half of this rectangle. Okay, these are the distribution is there. Always remember these things. Okay, always remember, otherwise you have to confuse. So this is very important problem, and I supposed to be asked in the upcoming gate question. Okay, beta. Now we have to move the next question. What is that? Please read this question. Beta. Read this question. Please read this question. So the motion of a hydraulic cylinder, this is your hydraulic cylinder is there. The motion of hydraulic cylinder is cushioned at the end of its stroke, by a piston that enters the hole as shown in figure. That means the piston will try to enter into the hole. The cavity and the cylinder are filled with the hydraulic fluid of uniform density rho. So in that one, that means in this all the things, there is a fluid is there which is filled in this gap. The fluid is filled in this gap. Obtained an expression from the average velocity V out, that means squeezing. That means if the cylinder is into the fluid will be flow the annular space. Why? Because this is your capital radius, capital diameter, and there is a capital diameter and there is a smaller diameter. In that one, so this is your capital R, and this is your small r. So this is your small r, this is your cylinder, and this is your capital R, this is your capital R, the small r, and this is your capital R. So in that one there is a fluid is there, annular space. So this fluid is out. Sorry, this fluid is out, V out. This fluid is V out, and the cylinder is in. This cylinder is in, V cylinder. They are asking that obtain an expression the average velocity of out. What is the average velocity out at which the hydraulic fluid escapes from the cylinder hole, assuming that the cylinder moves at a constant velocity. The cylinder will move at a constant velocity. They are asking like that. Okay, this is clear. We have to start this problem. So this problem is related to the conservation of mass principle. My dear, in the fluid mechanics, you have to note 2 and 3 points. What is that? In the fluid mechanics, there are 3 conservation. First conservation is conservation of mass. Second conservation is conservation of momentum. Third one is the conservation of energy. Conservation of mass, from the conservation of mass, the concept continuity equation derived. Conservation of momentum, the concept Euler's equation and Navier-Stokes equation is derived. Conservation of energy, the concept Bernoulli's equation is derived. This is first. Number second, in everywhere in the fluid mechanics domain, the fluid flow due to the 3 mechanism or combination of all the 3, yeah, combination of 2, yeah, only 1. Fluid move with the help of 3 distinct mechanisms. First one is displacement of a fluid boundary. That means the fluid will be moved. We have to displace the boundary. That is your cot flow. Like that, there is a dining table. On that dining table, there is a water is there. Let's suppose there is a water is spreading. Now you have put a cotton and you have to drag the cotton. So once you have to drag the cotton, the fluid which is stick to the cotton will also move. So that is movement is known as the boundary displacement fluid. That means the fluid will displaced due to the movement of a boundary. Second one, the fluid will move due to the pressure difference, like a Poisson flow. That means flow through a pipe. So in the pipe flow, the fluid is flowing due to the pressure difference. Number third, the fluid is flow due to the gravity. Fraud number, gravity. That means there is a plate, you have to incline the plate, fluid is automatically flow. So the mechanism of the fluid flow have a 3 mechanism. One is the displacement of a boundary. Second is the difference of the pressure. Third one is the due to the gravity effect. Okay. And also there is a 3 conservation: conservation of mass, conservation of momentum, and conservation of energy. So this question is related to the conservation of energy, momentum, mass. So what is the conservation of mass? Mass in minus mass out, yeah, rate of mass in minus rate of mass out is equal to rate of change of mass within the control volume. We know this thing. We know this thing in the differential form. What is that, beta? We know this thing. Conservation of mass. Conservation of mass. What is the conservation of mass? Mass flow rate in, mass flow rate exit. This is the net mass flow rate is equal to dmCV by dt. Clear now? Clear? Now my dear, so this is your differential form. If you write it is in integral form, how to write? First write this left term, that means d by dt, and this is your control volume. So integration of control volume And what is the mass? Density into volume. Density into volume dV. Okay. Plus this is related to the surface. This is related to the boundary. Control volume. This is related to the control volume. And this is related to the boundary, in or out, related to the boundary. So integration through the control surface. So this is integration through the control volume. This is integration through control surface. Why? Because entry and exit at is the boundary phenomena, and this is the within the system. That means control volume phenomena. So control surface density, there must be a relative velocity. Why? Because in or out, the fluid will move in or out in the either in the boundary is static or boundary is moving. So if the boundary is moving and fluid is also moving, so there must be a relative velocity concept. Velocity relative into the area dA. This is equal to 0. This is your continuity. So this is your integral form of this equation. And this is what, beta? This is what? This is your rate of change of mass inside the control volume. Rate of change in mass in control volume. This is what? This is what, beta? This is your net rate of mass leaves the control volume, leaves the control surface, and this is your dm dot. This is your dm dot. This is your dm dot, yeah, dmcv. So this is your dm dot, and this is your dm dot cv. Clear now? This is clear. So we have applied this equation. We have to apply this equation. We have to apply this equation. We have to apply this equation. Okay, so we have to apply this equation. This equation. Okay, this equation we have to apply. This equation we have to apply integral form. Now from this one integral form you have to take a control volume. How to take a control volume? So we have to take a control volume like that. Let's suppose this is our control volume. This is our control volume. What is the control volume? This is our control volume. Let's suppose this is our control volume. You have to assume any of the control volume like that. So only fluid we have to take a control volume. Okay, that means cylinder is a surrounding and the fluid is our system. So only fluid, control volume, we have to take only fluid. Only fluid. Okay. Now these control volume are deformable. Okay, okay. This cylinder is downward, this cylinder is downward moving. That means the control volume is a squeezing time. That means it will be moving control volume. That means these are the moving control volume. Cylinder is in, the fluid is out. So this is your like that deformable control volume. So this is what? Deformable control volume. So this is your deformable control volume. That means control volume is deform. Okay. So we have to apply this equation. So in this equation, beta, how to apply this equation? Please tell me how to apply this equation. So d rho by first, this is your first term and this is your second term. So if you write the first term, that means d by dt of integration of control volume rho into dv. Okay, this is your dv. So this is what beta? Simply dm cv by dt. Yes or no? This is simply dm cv by dt. Okay. Okay. And what is m? And that means d by dt. And what is the control volume? Rho volume of control volume. Yes or not? Okay. And it is like that beta. See, this is your outer casing, this is your cylinder. Okay. Okay, na? This is your radius small r, this is your radius capital R. Okay. And this is our system. Yes or not? So in this direction, this is your velocity of cylinder, and in this one velocity is out. Yes or not? Control volume. Density is constant, so rho dv cv by dt. Now the control volume continuously changing. Control volume continuously changing. So control volume continuously changing. So how to write? Rho d by dt. How to write? Control volume. So control volume. So this is out. What is the control volume? This length is this total length. This total length is L. Okay, na? And this is your x. So volume is what? Change in volume. D. So dt is write down and change in volume. So change in volume of control volume. So how the control volume changing? Initially the control volume, total control volume, and with respect to x the control volume changing. So what is that? Volume of at length L pi capital R square into L minus pi small r square into x. Yes or not? What is the volume? Control volume. What is the volume of control? What is the volume of control volume? So volume of control volume is what? Pi r square into L outer minus pi r square into x inner. So inner control volume minus outer control volume is the change in control volume. Inner outer surface. See this one. This is outer. What is the outer volume? Pi capital R square. This is capital R square into length L minus inner volume pi x pi small r square into x. Inner, differentiate it. The difference is your difference of control volume. So this is your volume, control volume. So how to write this one? This you write pi capital R square into the length is L minus smaller pi smaller square into x. This is your control volume. Change in control volume. That means, see this one. This control volume. So this is your length is L and this length is your x. So, and this is your radius R, capital R. So what is the volume of length L and radius R? आवाज कम आ रही है? Okay, just you recheck. Okay, आवाज is good, no problem. Sound is good, beta, no problem. Okay, so what is the dCV rho dt by what is the change in control volume? So कोई control volume is changing. You cannot take this is 0. Why? Because continuously the control volume changing. So what is the control volume change? How the control volume change? Pi R square into L is the outer volume. Pi small r square into x is the inner volume. So this is your length. Okay. So this is your how much? That means this is 0, pi r l, this all are constant, so minus rho pi r square dx by dt. And what is dx by dt? What is it dx by dt? What is the dx by dt? Dx by dt is the nothing, is the velocity of the cylinder. Dx by dt is the velocity of the cylinder. So this is your velocity of the cylinder. That means minus rho pi r square into velocity of cylinder. So this is your integration dt by dt of a control volume. Now second one is my dear, what is the second one? What is the second one? Second one is control surface rho relative velocity into dA. Yes or not? See, control surface rho relative velocity into dA. Okay, into dA. So this is your rho. And what is the relative velocity? What is the relative velocity? Relative velocity with of the motion with respect to the boundary. Boundary is, see the fluid is moving, this is out, so relative velocity is what? Relative velocity is what? V out. V out. Why? Because this cylinder move down, it will move out, but it will not cross it. That means the cylinder, it is pushing. Cylinder is not entering to the fluid, just is skewed. If the cylinder is entering to, why? Because this is our boundary na. This is our fluid boundary na. So this, in this fluid boundary, the cylinder is not crossing. Cylinder is not crossing, so the relative velocity of the cylinder is 0 with respect to out. If the cylinder is try to enter into the control volume, the relative velocity is have a difference. So what is the so this is your V out. So this is your V out, and this V out, let's suppose this is your y direction and this is your x direction. So V out into J. V out into J. Okay, minus what is the area? Out area. So what is the out area? So out area is your pi annular space. This is your annular space na. So pi capital R square minus small r square. Okay, this is also, it is your perpendicular. So this is also J vector. Why? Because this is your annular space, and this annular space also outward. So outward it is your y direction. So this is J. So how much it is? Rho V out into pi capital R square minus small r square. Clear? Now equate it. That means equating of this one and this one. That means you can add this one. So you can add, that is minus rho pi R square velocity of cylinder plus rho V out pi capital R square minus small r square is equal to 0. So if you find V of out, so this V of out is V of cylinder into small r square by capital R square. This is your required out velocity. This is your required out velocity. Clear? This is your required out velocity. So my dear, these are the simple application of the conservation of momentum. Okay. So how to find the relative velocity? Relative velocity is the velocity between the fluid and the boundary. That is, see, there is a boundary is displacing. So boundary is displacing. What is the speed to displace the boundary? V out minus V of cylinder, but V of cylinder is never cross it. It will just compress it. It will just compress it. It is not crossing. So V of cylinder, that means relative velocity is only V out. Okay, and area. What is the area? Area of this V out. So V out, it is the out area, the fluid out area. It is an annular space. So you have to write annular space. Now here you cannot take this is 0. Why? Because control volume, what is, you have to select the control volume. This is your control volume. You have select this is your control volume. This control volume continuously changing. This control volume continuously changing with respect to time. This control volume continuously changing with respect to time. So you cannot take 0. So the control volume, so this is what? dmCV by dt. And what is that? Rho into control volume. So dCV by dt. So rho you have to take outside, dt by dt. And what is control volume changing? How the control volume changing? Initial control volume. What is the initial control volume? This is the initial control volume. That means change in control volume. This control L length of the control volume minus X length of the control volume. So that is the net control volume. How to find this control volume? So this is always fixed. So how to find this control volume? Total length of the control volume pi r square L minus this X length of the control volume. Right? X is changing. X is changing minus. So put pi r square, this is constant. So differentiation is 0. So dx by dt, x, dx by dt. What is the dx by dt? X is what? X is the length of the cylinder. X is the length of cylinder. That means x is the distance at any instant. At any instant of time. So dx by dt is what? Velocity of the cylinder. So velocity of the cylinder. Now this you have to find. Now both you have to add this. You have to velocity out. This is the velocity out from this annular space. Clear? This is clear? This is clear, my dear? Now if it is clear, go to the next problem. This is very important problem also. Okay. Now the velocity of a particle of a gas flowing along the center of the pipe. So this is a pipe and the fluid is flowing along the center of the pipe. This is a particle, fluid particle. Okay, these are particles flowing along the center of the pipe in the figure is defined as x is greater than equal to 1. Limiting value x is greater than equal to 1. Okay. Okay. Now okay, now by the velocity field it is given v is equal to x by t, t by x. This is your t by x meter per second, where t is in second and x is in meter. If the particle within the flow it is at x is equal to 1 meter when time t is equal to 0. That means if particle at x is equal to 1, we have to start the measuring t is equal to 0. Determine its acceleration when it is x is equal to 2. First, my dear, please see this one. The velocity x, the velocity it is given in this question. The velocity is given. How? What is the velocity is given? T by x. See, if you check the unit, this is your meter per second. This is your second per meter. This is not a unit of velocity, but here is your unit is given meter per second. If you take this one, this is not a unit of velocity. It is your second per meter. Second per meter. But in this question, it is given meter per second. First confusion in the student community is this one. Okay, sir, how we have to understand how it is given. My dear, it is not direct. It is directly it is given, but in there is a constant term is there. They are not showing in this one. There is a not showing is this in this figure. So what is that, beta? Here must be a constant. What is the constant? If you multiply 1, so this is your meter per second. So this is your meter per second. So there is a constant is meter square. So this is your second per meter. Now if you multiply the constant term, let's suppose any constant 1 meter square second square. You have to multiply it. So this meter cancel, this second cancel. So what is the unit? Meter per second. So it is any constant, that means this is your V is equal to any constant K T by X, and this is given meter per second. And how it is? Why? Because constant, the unit of this constant, let's suppose this is 1 meter by second the whole square. Clear? Meter by second the whole square. Clear, beta? It is given like that. It is given like that. So the unit is automatically, this is your meter second by meter, and this is your meter square by second. Meter cancels, so this is a meter by second. So this constant is hidden. That means there must be a constant which is not shown. In this question it is not shown. So don't confuse. You don't think that sir, the question is wrong. Why? Because the unit is wrong. No, there must be a constant which is not shown in the figure. Okay, number first term. So they find the acceleration of this fluid particle at x is equal to 2. Now my dear, let's see something inside there. Okay, so if you see the velocity profile, this velocity profile, if you see the velocity profile, my dear, what is the velocity it is given? Velocity it is given t by x meter per second. The velocity it is given or not? Please tell me. This is the velocity is given. Now my dear, this velocity is a function of time as well as position. Yes or not? This velocity is a function of time as well as a position. That means this velocity is unsteady with non-uniform. Yes or not? That means this velocity is a function of space and time. That means this velocity is non-uniform plus unsteady. Number first. Number second, this velocity is one dimensional or two dimensional or three dimensional? This velocity is one dimensional velocity. Okay, this is your one dimension. Something observation is there. Okay, now my dear, this x is changing. This x is changing continuously with respect to time. Not fixed. Not fixed. X is changing. X is 1 meter, x is 2 meter, x is changing with respect to time. So x is changing. That means Eulerian approach. What is that? Eulerian approach. That means all particles passing the location x have a velocity changing with time. Okay, so what is the Eulerian approach? So we have to material derivative or total derivative. What is that? Acceleration A is dv by dt. Okay, what is this one? If you split that, dv by dou t plus v dou v by dou x. Why? Because it is in x direction only. Okay. Now v is your, so this is your 1 by x plus v is your t by x. If you differentiate with respect to x, minus t by x square. Clear? This is your acceleration. But my dear, please mind it, we don't have any time value it is given. So first we have to find time. First we have to find at a particular location, at a fixed location. So we have to fix the location, flow the particles. So we have to fix the location, okay. And so how to find this time? That means we have to find the time at particle starting time x is equal to 0. That means x is equal to 1 meter, the time is equal to 0. Now x is equal to 2 meter, what is the time they are asking? So we have to put here. Why? Because we have to find the acceleration at x is equal to 2. We have to find the acceleration at x is equal to 2. So we have to find the time at x is equal to 2. So for that one, what we know that, very important, now we have to find the time for the particle to travel from x is equal to 1 meter to x is equal to 2 meter. That is, x is the function of time. That means x is equal to 1 meter, time is equal to 0, and we have to find x is equal to 2 meter. So so we have to fix the location. That means we have to find x is equal to 2. So fix the location with respect to time, that we have to do the Lagrangian approach. Lagrangian description. This is your Lagrangian description. Since we must follow the motion, that means why? Why? Because since we have must follow the motion of a single particle. Okay. So what is that Lagrangian? V is equal to dx by dt. What is V, beta? This is your t by x. So this is x dx t dt. Now you have to integrate x is equal to 1 to 2, 1 0 to t. So this is how much? X square by 2 minus 1 by 2 is equal to t square by 2. Now from that one, what is x value? So here we have to find x is equal to root under t square plus 1. So x is equal to 2 is equal to square root of t square plus 1. So t is equal to 1.73 second. So this is a time to take the particle from location at 1 equal to location at 2. So t is equal to this one. Now put the acceleration. So we have this acceleration. So the acceleration it is, we know this acceleration it is 1 by x plus t by x, we have minus t by x square, yes or not? Now what is 1 by x? 2 plus t is what? 1.732 t square root divided by x is 2 minus 1 by 2 square. If you put this value, this is your 0.125 meter per second square. This is the acceleration at x is equal to 2 meter. This is very good question, I am telling you. In this question, both approach you have to take Lagrangian and Eulerian. Clear? This approach we have to take a Lagrangian as well as Eulerian. How? See my dear, this is the equation. First we have to understand what is the given it is. Second we have to try to understand how to define the Eulerian approach. The Eulerian, if you define the Eulerian approach, the material derivative that is the field approach. What is the, see my dear, what is the difference between Eulerian approach and Lagrangian approach? This is very important. See, first we have to take a Lagrangian, then Eulerian. What is that Lagrangian approach? Lagrangian approach is a particle approach. Lagrangian approach is a particle approach. That means you have to take a fluid particles, single particle. Eulerian approach is a control volume approach. Okay. Now how to understand that? That means there is a, you have to fix the control. That means you fix a region and what, and look and see the region. Only the fix the, that means you fix the camera and focus the camera on a particular region, and then you have to analyze. So the analysis is your Lagrangian approach. Sorry, Eulerian approach. That Lagrangian is your, that approach is your Eulerian approach. Now Eulerian approach, don't bother about from where the fluid particle is coming and where it is going. Only we have to fix the zone. That means if you fix the zone, that means that is a control volume approach. Now in the Lagrangian approach, that is a particle approach. That means we have to track individual particles. Number first. Number second, that means Eulerian approach is applicable for the control volume and Lagrangian approach is applicable for the control mass system. That means a mass. That means a free body diagram, the concept of a free body diagram, if any body and you have to take a concept of free body diagram, that means a body will convert into particle, that is your Lagrangian approach. Okay. Number second, the Eulerian approach is your field approach. That means there is a field is there. But in the Lagrangian approach, there is a particle approach is there. In the Eulerian approach, we have to derive the material derivative, dV by dt. That means a total derivative. Okay. But in this case, we have to take the derivative of a single fluid particles. You have a single fluid particle. So this V is equal to dx by dt. This is your particle approach. That means a body of a mass m, which is your moving a distance x and taking a time t. So what is the velocity? Dx by dt. So this is your particle approach. So this is your Lagrangian approach. This is your Lagrangian approach. So and this is your Lagrangian, and in the Lagrangian approach, the x is the function of time. X is the function of time. That means we have to take a Lagrangian description, since we have must follow the motion of a single particle, single fluid particle. So be careful, in this question we have to take a single particle, we have to derive this equation, we have to find the time for the particle. So we have to find the acceleration of that particle. So if you find the acceleration of the particle, there must be a field approach. So for the acceleration of the particle, we have to find the time. So for that time, why? Because this derivative it is given, there is a time is required. So we have to find the time at the particle when it is at 2 meter. So at a 2 meter, what is the time? So if you find, that means if you at a fixed position and you follow the fixed, so this is your at 0.2 meter. So at 0.2 meter, what is the time? So you have to find the time 1.73. That means x is equal to 0 the time is equal to 1 meter and x is equal to 2 meter, the time is 1.73 second. From that one you have to easily calculate what is the acceleration. Clear? Clear? Yes or not, please, beta? Tell me. This is clear? Yes or not? Please tell me. This is clear? Please tell me. This is clear, beta? This is clear? Yes or not? Please tell me. This is clear? Yes or not? Please tell me, beta. This is clear? Okay. So we have to start the next problem. What is the next problem? This is the next problem. Very good. This is the next problem. Please see this problem, beta. Please read this question. Sometime, so what is that? This question is related to please read this question, beta. So this question, see this one, an incompressible, that density is fixed, incompressible viscous fluid with density rho flows past a solid plate. So this is your solid plate which has a depth b, that means this plate have a perpendicular distance to the board b into the page. The flow initially has a uniform velocity before encountering the plate, that means before, that means this is a free stream velocity, that is called free stream velocity. Okay. Now after contact with the plate at a distance x, this is your downstream, this is your upstream. So upstream velocity profile, this is your downstream velocity profile. So downstream from the leading edge, this is your leading edge, this is your trailing edge. From the leading edge, the flow velocity profile is altered, that means the flow velocity profile is disturbed due to the no slip condition. The velocity profile at that location x is estimated to have a parabolic shape. That means this is a, let's suppose you have to define a parabolic shape. What is the velocity profile? At any y distance, u infinite 2y by delta minus y by delta the whole square. For y, and this is for y less than equal to delta, that means this is your within that one. And u is equal to infinite when the y greater than delta, where delta is termed the boundary layer thickness. My dear, this dotted line is the edge of a boundary layer. That means if the fluid is flowing from a free stream, the fluid due to the no slip condition, the fluid on the plate at that point, the tangential velocity along the plate direction is 0, relative tangential velocity. That means is this point the relative velocity is tangential 0, so that there is a momentum diffusion takes place from the plate to the fluid in the perpendicular direction. So due to the momentum diffusion, there must be a boundary layer growth. So what is the significance of this boundary layer? Above the boundary layer there is a inviscid fluid. Below the boundary layer, that means the fluid which is a certain height from the plate in the perpendicular direction have a feel the viscosity, and that have a zone known as boundary layer. We will discuss, okay, boundary layer thickness. Now determine the upstream height from the plate H, from the plate H. That means what is the height? That means there is any streamline. Why the streamline deviated upward, beta? Anyone can tell me? This streamline is deviated upward. Why the streamline deviated upward? In this case, why the streamline deviated upward? Why? Because see my dear, see my dear, here let's see here to here the velocity is decreases. Yes or no? The velocity is decreases. So velocity is decreases, the mass flow rate is reduced. Mass into velocity, that means mass flow rate is reduced. But due to the steady flow, what is the mass flow rate is there? The mass flow rate is there. So this compensation of this reduction mass flow rate, we have to shift the streamline. That means this streamline is higher. That means delta is higher than H value. Clear? Understood? Again we have to discuss why this streamline deviated upward. This is my question. Why this streamline deviated upward? Why? Because at this section the velocity is higher as compared to this velocity. Why? Because there must be a loss in kinetic energy from this direction to this direction. So there must be a loss. That means a velocity will lower at this position as compared to this position. So the mass flow rate is less as compared to this position. That means mass flow rate at the leading edge is less than the mass flow rate at the trailing edge. Why? Because the velocity is same. But there is a steady flow. That means there is a steady flow. That means what is the mass flow rate is there? The mass flow rate is there. So to compensate the same mass flow rate, you must be shift the area of this. We must be shift the length of this one, so that the what is the mass flow rate is there? The same mass flow rate is there. So the streamline is deflected upward. Streamline deflected upward. Okay. Now, so there are two zones. One is the delta y less than delta. This is the zone where y is less than delta, and this is the zone where y is greater than delta. And y equal to delta, that is called edge of a boundary layer. So they are asking that what is the H value? What is the H value? Okay, of the streamline which have a height of a streamline which has a height delta at the downstream distance. So this is your streamline. So streamline distance at upstream is H and downstream is a delta. So what is the H height? Okay, express your answer in terms of delta. Okay, now second, determine the force on the plate exerted. Determine the force the plate exerts on the fluid over the distance x. That means you have also determined the force. Express your answer in terms of rho, u infinite, b and delta. You may be assured that the pressure everywhere is P infinite. That means the pressure is constant, either upward direction or either in downward direction. Okay, that means in this vertical and horizontal direction pressure is constant. The force the drag exerts on the plate is called skin friction drag. So you have to find the drag force on the plate also. Clear? This is clear? This is clear, beta? Everyone please tell me. So if you, so first part if you find the H, we have to apply the conservation of mass. The second part, the force, we have to apply the conservation of momentum. So conservation of mass integral form and conservation of momentum integral form equation, we know that things. Okay. So if this is our plates, so we have to take, this is our streamline, yes or no? This is our streamline. So we have to take, this is our control volume. Red dotted line is our control volume. So my dear, one thing is very important to note down. If this is the streamline, so mass is in here, yes or not? Possibility, mass is in here, mass is out here. Here also mass is out, here also mass is out here. So there are 4 zones, the possibility, but we will check on which zone the mass flow rate is possible. See my dear, this is in, yes, in this one there is a in, there is a gate is there, so mass is in. Now this is a solid plate, there is a no any penetration on the plate, so there is a no mass out flow from the plate. Okay. Now this is your streamline, so there is a no flow across the streamline. So if this is your streamline, there is a no flow across the streamline, so this is also 0. But this is there. So in this direction mass is in and mass is out. There is no any mass out from the upward and downward. It is clear. Why? Because there is no any mass flow rate in this direction. So this is our control volume, na? Let's suppose this is our control volume. So in this control volume, this is our control volume. What is the control volume here? So this is look like a control volume. See, this is our control volume. Yes or not? This look like a control volume. So this control volume here, the mass is in, mass flow rate in. Here the mass flow rate out. Here is no, why? Because this is a solid boundary, no mass flow rate in, out. This is your streamline. So also there is no any mass flow. That means if there is a mass flow, there is an intersection of the two streamline, and we know that there is no any intersection of the streamline. The streamline can never be intersect to each other. So there is no. So only mass in and mass out is there. So according to me, this height is delta. This height is delta, and this height is h. So this velocity profile is linear, and this velocity profile is parabolic. This velocity profile parabolic, and this velocity profile is linear. Clear? This is clear. So this velocity profile, it is linear. So here, let's suppose this is our gate. Yes or not? Through which the fluid is enter. Yes or not? Which velocity? V velocity. Okay. This is our gate where the fluid is exit. Where the fluid is exit. And the exit, it is in parabolic. That means all the point the fluid will change, velocity change. But here all the point the velocity is same, velocity is same, velocity is same, velocity is same, velocity is same. So velocity is same, and that velocity is u infinite. Okay, that velocity is u infinite. But here the velocity is changing with respect to y, and that velocity changing with respect to a parabolic condition. Okay, this is clear. So we have to apply the conservation of mass. We have to apply the conservation of mass. Conservation of mass. What is the conservation of mass, beta? D by dt integration of, this is your control volume, rho into dv, this is a volume, plus integration of control surface rho, this is your relative velocity, into dA vector. Clear? And that is equal to 0, incompressible. Okay, that is equal to 0. Okay, note down. No. Now the flow is steady. The flow is steady. What is the flow, beta? The flow is steady. The flow is steady. Flow is steady. That means this is your 0. Why? Because steady flow. Steady flow. So only we have this one, control surface rho relative velocity vector into dA vector. Okay, we have to find this one. Okay, clear? Now we have to draw like that. See, my dear, this is our control volume. Yes or not? This is our control volume. Here the velocity profile is linear. Yes or not? Very clear. Here the velocity profile is parabolic. Yes or not? Yes or not? Yes or not? Now this is height h, and this is height delta. This is height delta. Okay, this is the velocity of u infinite inter, and this is the velocity u, and it is also given. Okay, now so this is what beta? out minus in, yeah, in minus out you have to take like that. So what is in here? So there are two type, in minus out, mass flow rate in. So what is that? Rho is constant, so there is no integration. Why? Because it is uniform. So rho, it is there. U relative, it is entry, and this control volume is fixed. This is fixed control volume. Fixed control volume. It is not moving. So what is the entry velocity? U infinite. Clear? And this U infinite, this is your x direction, and this is your y direction. So this U infinite into I cap. Yes or not? I cap into, what is the area? This area is what? H into unit width B. B is the width is there. So the area is your H into B. And this always perpendicular to the outward direction. Perpendicular to the outward direction. So this is your minus J minus I. Why? Because this is always perpendicular to the, this is your n cap. Always perpendicular to the outward. So minus. So what is this one? First, okay. So this is your, this one plus. Now the control volume, now this is your control volume. So integration and surface, it is your from 0 to delta. 0 to delta, and this is your differentiation with respect to y. That means y is equal to 0 to delta into density. Clear now? Into density. What is the relative velocity? What is the relative velocity here? Relative velocity only u. And what is the u here? It is given. U is equal to u infinite into 2y by delta minus y by delta ka whole square. This is the relative velocity. This is the velocity. So put this velocity here. U infinite 2y by delta minus y by delta ka whole square. Yes or not? Yes or not? So this is relative velocity. In this direction, I direction. So this is I direction dot dA. Now my dear, here this area is, all the gate are uniform, but the here area is differ. This area is differ. So let's take this dA elemental area. Why? Because beta, see this area is differ na. This area, the gate. Why? Because if you take this one, so another mass flow, another mass flow. Why? Because velocity is changing. But in this one, all the gate, if you take all the size of gate, but if you take this size, this size, this size, if you take this elemental size, so in this one the velocity is u infinite. But if you take in this one, the velocity is differ. In this, take this one, the velocity is differ. So in this one, the area is differ. So what is the area here? So let's suppose this is a dy. This area have, this gate have a dy, and this is your b. So b into dy, b into dy, and this is your positive I. Why? Because in this one there is a outward. In this one there is a outward n cap. Clear? This is your positive. Okay. Now, so if you have rearranged like that, what is that here? Minus rho u infinite h into b, yes or not, plus rho u infinite b you have to take outside. Rho u infinite b you have to take outside. Integrate this one. So this is your delta minus 1 by 3 delta. This is 0. Okay. From here, if you solve this one, the h value is 2 by 3 delta. 2 by 3 delta. This is your 2 by 3 delta. So this, see, this height is less delta. So from here H is less than delta. A simple calculation is there. Okay. Now, if you find the drag force on the plate, if you find the drag force on the plate beta, that means you apply the integral equation, momentum integral equation. So my dear, see this one. I give you one clue is for that one. So we have to find conservation of linear moment, conservation of linear moment. So this is your conservation of linear momentum. What is the force equation? That means what is the conservation of linear momentum? Force equation. This is your force equation. This is your force equation. So conservation of mass is the integral form. What is that? Force. So we have a mass multiply with the velocity. So apply conservation of momentum in, so this is your x direction. This is what beta? This is your x direction, na? This is your x direction. This is your x direction. This is your y direction. So we have to apply the conservation of momentum in x direction. In x direction. Okay. So what is the mass flow rate multiply with the velocity? What is mass flow rate multiply with the velocity? So first is the control. So first is d by dt, and this is your control volume. Control volume. Okay. Same rho into dv multiply with the velocity in x direction. Clear? Plus integration of control surface. Okay. So here rho, yes or not, rho u of relative vector into dA multiply with x direction. That's it. So this is your force. This is your indirectly mass into acceleration is equal to, there are three forces: body force, surface force, two force, body force and surface force. Surface force have two force. So body force in x direction plus surface force in x direction. My dear, this surface force have a two component. One is the pressure force and other is the, so one component is your pressure force in x direction, other component is your viscous force, that is drag force, viscous force or a drag force. So this is your viscous force or a drag force in x direction, viscous force in a drag force. Now my dear, here the pressure is uniform throughout, so this is 0. Pressure is uniform, they are saying atmospheric, so these are 0, no pressure force. Now the viscous force, see my dear, now this is very important to discussion. See this one. This is our control volume, yes or not? This is fixed and this is streamline. Okay. Okay. Now at this surface x direction, this is 0. So Vf x direction 0. At this surface Vf x direction 0. Why? Because it is wider. Now what is the surface force at this direction, at this force, this streamline? Please tell me. What is the surface force at this streamline? Please tell me. What is the surface force at this streamline beta? See, what is the velocity of this streamline? What is the velocity of this streamline? What is the velocity here? Arre, u infinite. What is the velocity here? Arre, u infinite. Yes or not? Yes or not? This is the delta. This is your delta and this is your h. You know this. So at this point edge, this is your this point. So here this is your boundary layer, na? This is like that. So at this point the velocity is infinite. At this point the velocity is infinite. So this is a velocity infinite. Now my dear, so velocity is not changing. Now the streamline, so along the streamline there is no any viscous force. Why? Because this is your viscous, this is what? This is what? This is your viscous region. Yes or not? This is within the boundary layer. Within the boundary layer. So within the boundary layer, viscous force is there. But this streamline is above the boundary layer. Yes or not? This region is above the boundary layer. Above the boundary layer. So above boundary layer, viscous force is 0. Viscous force is 0. So on this line there is no any viscous effect. On this line, this streamline, there is no any viscous effect. No any viscous effect. So in this one there is no any viscous. So on this one there is also no any viscous effect. So only viscous effect at this zone, and this is called drag force, Fv. So this viscous force is opposite. This is an x direction, na? So this viscous force is opposite to x. So this is only minus of F. Clear? Clear? This thing clear? Now we have this one. We have this one. This is a minor. So this is 0. Body force in x direction, it is 0. So only equal to minus of F. Now you have to calculate this term. You have calculate this term. You have calculate this term. Okay? If you calculate this term, the answer it is F. Put the value and find the answer. 2 by 15 rho u infinite ka whole square b into delta. That's it. Clear? This is clear, everyone, please? This is clear now? So my dear, now today I stop the session here. Tomorrow we'll start the session at 6 p.m. starting from here, and we have to solve some problem with related to the boundary layer, and something very good problem is there. So you have to just practice of this problem. This problem you have to practice all this thing. Calculation is there. Concept is finished. This concept is finished. There is a concept is that one. What is the concept is this one? This is a very important concept. No any can tell this concept for this one. On a YouTube channel I am telling you. Why? Because this is very important. Why this is 0, why it is not 0. This is like that. Okay. So just keep in mind, there is only mathematical. You know this calculation. You know this calculation already in the conservation of mass principle. So you have this one. You have this one. You have this one. So only the matter is that how to write, how the minus f is there. So please be understand of this one things, and also be careful applying the while calculating this calculation. If there is any problem while calculating this problem, please comment in the comment box. I will discuss tomorrow. Okay. Up to that, stay tuned. Thank you. Bye bye.